So in this particular lecture, we will discuss some problems related to impulse signal, discrete time impulse signal, and we'll see how we can apply the properties of impulse in this particular problem. In the first question, it is given x of n is equal to sigma n is equal to minus infinity to infinity e raised to n del of n minus 2. So we can write the definition of a discrete time unit impulse signal. So discrete time unit impulse signal, which is represented by del of n, which is equal to 1 for n is equal to 0 and 0 for n not equal to 0. And if you draw the waveform, it will be like this. At n is equal to 0, the function magnitude is 1, and for all other values, for 1, 2, 3, etc., and for minus 1, minus 2, minus 3, the function magnitude is 0. That is del of n. Now we can see that in this particular question it is given del of n minus 2. It's a shifted version of impulse signal. So del of n minus 2 is equal to 1 for n minus 2 equal to 0, or you can write n is equal to 2, and 0 for n minus 2 not equal to 0, or n is equal to n not equal to 2. And if you draw the waveform of del of n minus 2 at n is equal to 0, 1, 2, 3, etc., minus 1, minus 2. And from this particular expression, we know that at n is equal to 2, the function magnitude is 1. So at n is equal to 2, the function magnitude is 1, and for all other values of n, the function magnitude is 0. So this is summation actually from minus infinity to infinity, but the del of n minus 2 exists only at 2, n is equal to 2. N is equal to 2. So we don't want to evaluate this summation for the entire limit. We will evaluate only at n is equal to 2. So if you evaluate, you will get e raised to 4. Okay. Now, if you take this particular question, a similar question, but here it is given del of n minus 1 and sine 2n, and we need to find the summation from minus infinity to infinity. So del of n minus 1 can be written as 1 for n minus 1 equal to 0, or n is equal to 1, and 0 for n minus 1 not equal to 0, or n is equal to not equal to 1. And if you draw this particular waveform, this is n, and n is equal to 0, 1, 2, minus 1, minus 2, etc., and the signal magnitude is 1 when n is equal to 1, and for all other values it's 0. So at n is equal to 1, it's 1, and for all other values it is 0. Okay, that is del of n minus 1. That's a shifted version of impulse signal. So if you multiply these two signal, del of n minus 1 having non-zero magnitude only at n is equal to 1. So we don't want to evaluate the equation for the entire limit. We will evaluate only at n is equal to 1. So if you put n is equal to 1, it becomes sine 2. In this particular question, again, we need to find the summation n square into del of n plus 2. So if you write the definition of del of n plus 2, that is a shifted version of impulse signal, discrete time impulse signal. So del of n plus 2 is equal to 1 for n plus 2 equal to 0, or n is equal to minus 2, and 0 for n plus 2 not equal to 0, or n not equal to minus 2. And if you draw the waveform, this is 0, minus 1, minus 2, minus 3. This is 1, 2, 3, etc. And the signal is having non-zero magnitude only at n is equal to minus 2. At n is equal to minus 2, the function magnitude is 1, and for all other values, it is 0. Okay. So we don't want to evaluate the summation from n is equal to minus infinity to infinity. We will evaluate is only at n is equal to minus 2. When n is equal to minus 2, it's minus 2 the whole square, so which is equal to 4. So here the summation is from 0 to infinity, not from minus infinity, because n is equal to 0 to infinity. And the impulse signal is given del of n minus 1. So you can write is equal to 1 for n minus 1 equal to 0, or you can write n is equal to 1. And 0 for n minus 1 not equal to 0, or n not equal to minus 1. And if this not minus 1 is plus 1. N, and this is 0, 1, 2, this is minus 1, minus 2, etc. And the function magnitude is 1 when n is equal to 1. So you can draw a waveform like this, and this is del of n minus 1. And if you observe the summation is starting from n is equal to 0 to infinity. Okay, 0 to infinity, and this del of n minus 1 exists at n is equal to 1. So we can evaluate the summation only at n is equal to 1. So if you substitute n is equal to 1, it becomes t. Okay. Now, in this particular question, again the summation is from n is equal to 0 to 5, not from minus infinity to infinity. It's very important. Always observe the summation and the discrete time impulse signal. Here the del of n plus 1 is given. Del of n plus 1 is equal to 1 for n plus 1 equal to 0, or n is equal to minus 1, and 0 for n plus 1 not equal to 0, or n not equal to minus 1. And if you draw this waveform, you can observe that 0, 1, 2, this is minus 1, minus 2, this is 3, 4, and 5. And the signal exists at n is equal to minus 1. So at n is equal to minus 1, the function magnitude is 1. And for all other values, it's 0. And if you closely observe the summation is from n is equal to 0, okay, and 0 to 5 we need to evaluate. N is 0 to 5. But if you observe the signal del of n plus 1 exists only at n is equal to, or it our non-zero magnitude only at n is equal to minus 1. But the summation is from 0 to 5. From 0 to 5, del of n plus 1 values are 0. And if you multiply it with 2 raised to n for this particular region, if you multiply e raised to 2n into uh, del of n plus 1 in this particular region, it becomes 0. Okay, so if you evaluate this particular summation or the interval 0 to 5, you will get 0, not 2 raised to some n is equal to minus 1. So always remember that when the limit is outside the summation, or discrete time sequence impulse signal exists outside the summation, your result becomes 0. Here n exists only, the del of n plus 1 exists at minus 1, but the summation is from 0 to 5. If you observe the values of del of n plus 1 from 0 to 5, it is 0. And if you multiply with 2 raised to n, it becomes 0 within this limit. N is equal to 0 to 5.